Hello. This topic is talking about laws of positive integral index. First, let's revise some topics we learned in Form 1. When there are two numbers, right, with same base take product, then we know that the result is the base and then sum the index. For example, when x to power 13 times x to power 24, because they are same base, right? So as a result, you find that you can sum the index as a result equals to x to power 37. But now, when you perform division with the same base, we have in Form 1, we have learned that we need to subtract the index here. But which one minus which one depends on which one is larger. For the first one, okay, for example, okay, when x to power 23 divided by x to power 15, and this time you find that numerator is larger. So the resulting index, we use the larger index minus smaller, so that means it's 23 minus 15, and the result x to power 8. And because the numerator is larger, so this time you find that is x to power 8 only. But another case, for this one, when y to power 9 divided by y to power 22, alright, this time you find that denominator is larger. Alright, so in this case, the index law, you still use larger index minus small index, but this time is 22 minus 9. But because this time the denominator is larger, so this time is 1 over the y to power 22 minus 9. As a result, is 1 over y to power 13. In this case, you find that if the denominator is larger, then you still use the larger index minus small index, but a to power this index but become 1 over to a to power something. Alright, now we would like to consider this one. This one is a to power n and to power n. Alright, so we would like to use the example when a and for this one is 5 squared and then to power 3. For this one, it's just like the product of 5 squared. And by index law, you can sum these three index, so you find that is 2 plus 2 plus 2. And then that means because 3 2's sum together, that means you can present it as 2 times 3. As a result, this one is 5 to power 6. And for this one, when you compare these two, you find that the result index, right? Result index is the product of these two index only. That means that when we meet a to power m and then to power n, this time be careful, you find that is power to power, okay? Power to power. You find that only one base only, and with 2 power here. In this case, right, you find that when to power m and then power n, the result index, you only need to product the index. Right, so for this also, as a result, you will find that because they are when a to power m and then n power, right? That means that a to power m is product itself n times. So by index law, you sum the m n times, okay? As a result, you find that when a to power m to power n, you find that the result power is m times n. So as the result is a to power m times n. Right, for example, when x to power 6 and then to power 9, you find that only one base, okay? And first take power 6 and then power 9, okay? So from index law, you find that is power. So this time you just take product index. As a result, there is x to power 54. Alright, now try this. Alright, now we would like to try this example, okay? Alright, part A. part A, right? Alright, now we want to simplify this one. Alright, so a to the power 4 times a cube and to the power 5, right? First, we process this one. For this one, you find that product, same base, right? As a result, because same base, the product, you can sum the index. That means 4 plus 3, right? You keep power 5, right? And so you find that is a to the power 7. So for this one, you find that a to the power 7 and then to the power 5. So on one base, power to power. So as a result, is a, say a is base, right? But this two index, you take product. As a result, is a to the power 35. Alright, another example. And b to the power 9, or dy, okay, I would like to present like this, b to the power 6 and to the power 4. Right? Well, we keep it b to the power 9, and b to the power 6 to the power 4. Power to power, so b and result power is 6 times 4, right? Just product of power, so b over power of 9, and b to the power 24. And this time is the division. Division now, same base, right? As a result, we have subtracted index. And because you find that the denominator is larger, so you find that is the result is you use larger index minus smaller index, but because is larger in denominator, so this time the result is 1 over. And b use larger minus smaller index, so 24 minus 9 as a result is 1 over b to the power 15. Well, now we will consider when AB, the product, and to the power n, okay? And for this one, when 3x and then overall to the power 4, that means it's a product of 3x, right? And you find that all these x, right? All these x factor just product together, so this 3 can become the product 3 to the power 4, and this x times x times x times x, this 4x can become x to the power 4. So as a result, you will find that in this product and overall take the power, then the result can become each factor take the same power and then take the product. Okay, just so as a result, when AB, right, and the product and then the whole AB take the product the power n, then it will be the same as each factor take the n power first and then take the product. Right? And when we meet the fraction, okay, right, so for example, when y over 3 take the power 4, okay, so it's the same as the y over 3 take the product itself 4 times, okay, and this 4y can become y to the power 4, and this 4 and this 3, right, 3's can become 3 to the power 4. As a result, you will find that when the fraction take the same power, then the numerator and denominator will take the same power, just like this. Alright, so here are the examples, okay? When 2p take the power 5, okay? So when the product take the power 5, that means the 2 and p, each of them take the power 5. As a result, p to power 5 and 2 to power 5 is 32. So as a result, it's 32p to power 5. And 3 over k to power 4. And in the fraction, okay, because take the power 4, so for this one, in this fraction, each numerator and denominator can each of them take the power 4. And 3 to the power 4 is 81, so as a result is 81 over k to the power 4. Alright, now let's try this example. Alright, for question 1, okay, is overall, okay, 3y, okay, 3y to the power 5 and power 4, okay. Alright, now we find that with 3 times y to the power 5 and overall take power 4, okay. So in this one, for this 2, each of the, by inverse law, these 2, okay, each of them can take power 4. That means 3 take power the power 4, and y to the power 5, and then to power 4. And 3 to the power 4 is 81, and y to the power 5, okay? And then to the power 4, so power to power, so you find that is 5 times 4 in the result index, okay? So the result is 81y to the power 20. And next one, minus k squared to the power 6, okay? For this one, and for this minus, okay, be careful that the square, okay, the square control the k only, okay, but this square is not related to this minus sign. Be careful, okay. So in this case, when you try to break down, is minus 1 times k squared and the power 6, okay. So minus you can think that is a minus 1. So if this one is minus 1 times k squared, and so as a result, you will find that there are two factors, okay, and overall take the power 6, okay. So by index law, each of them take the power 6, so that means minus 1 take power 6, and this one take the power 6, k squared, and then power 6, okay. And minus 1 to power 6, that means that is 6 minus 1 product together, so as a result, you find that the minus sign can be cancelled, okay. And then this one, k squared to power 6, and you find that is power to power, so the result is 2 times 6 in power, then that means that equals to k to the power 12. And then for this one, I'll keep square, over 2 is power 5, okay? And we learned that it is a fraction, so each of them take the power 5. So I'll take power 5, and square also power 5, okay? And 2 to the power 5, we know that is 32, and then it's power to power again, so 3 times 5 in result power, okay? As a result is 3 times 5 in index, so the result index is 15, so it's r to the power 15 over 32. Right now, we try the example 5a to the power 4b squared and keep, right? Right now, you know that there's a fraction here, alright, so something over something. So in the fraction, because it's a fraction, so each of them can have the power 3. So 5a to the power 4, and then the whole take keep, and b squared take keep away. And then, right now for this one, you find that the product and take the keep. So the product is this two. So the overall take keep. So each of them can take the power 3. So it's 5 keep and 4 to power and 8 to power 4, and take keep. And then b squared 2 keep. And then 5 keep is 125, and a is power to power again, so 4 times 3, you find it 12, okay? And b, 2b squared and 2 keep, okay? Power to power again. So as a result, this index is 2 times 3, that means it's b to power 6. And this one cannot be cancelled anymore, so you finish, okay? Alright, so that's the end. So please take more revision and do more exercise. Thank you and bye bye.